Okay, so we will solve this numerical. A ladder 5 meter long and 250 Newton weight is placed against a vertical wall in a position where its inclination to the vertical is 30 degree. A man weighing 800 Newton climbs the ladder. At what position of will be induced slipping? The mu, that is coefficient of friction for both the contact surface of ladder, that is with the wall and floor, is 0.2. Okay, so we will understand the question itself. We will understand what is the given data in the question and what we have to find out. Okay, so length of ladder 5 meter long is given, and we can draw a sketch like this. Okay, so this is the wall, this is the ground, and this is that ladder. Okay, so at point A it is contact with the wall, and at point B it is contact with the ground. Okay, so then weight of that ladder is given 250 Newton. We can show it at center, so 2.5 meter. Total length is 5 meters given, so that will be at center, so 2.5 meter from point B. Okay, then vertical wall position where inclination to the vertical is 30 degrees. So inclination of that ladder means vertical wall is given, so that is 30 degree angle is given. Okay, a man weighing 800 Newton, so weight of man is given 800 Newton, climbs the ladder, and at what position will be induced slipping? So we have to determine, let's say this distance as x, we have named it as distance x, so we have to determine this distance x. At this position of the man, the ladder will start slipping. Okay, so first we have to understand, when the ladder is going to slip, that will be slip like this. So at point A, contact will be at point A, that point A ladder will move downward, whereas at point B the ladder will move towards left. Okay, so this will be the direction of motion towards left, and at this point that will be downward. Okay, so then we have to draw the free body diagram of that ladder. So drawing the FBD, so removing all the support. So when we remove the support at point B, so here support is horizontal, so normal direction NB, that will be perpendicular to this support. Okay, then here when the motion of this point B or the ladder at point B will be towards left, so friction force will be towards right direction. Okay, then at point A, motion of point A of the ladder will be downward, so friction force here will be upward, FA will be upward, and here again the normal surface, the support is vertical, so normal reaction perpendicular to the support, so that will be horizontal. Okay, so that will be the free body diagram. And when we see this FBD in terms of number of unknowns, so at point A one unknown is there, because when we know the NA we can determine the FA, so here one unknown. Again similarly here, if you know NB, we can determine FB, so here again one unknown is there, and this distance x, so total number of unknowns are 3. Okay, so if number of unknowns are 3, then we must have 3 equations, okay, to solve that numerical, and that 3 equations will get from the 3 conditions of equilibrium. Okay, which are they? Summation fx0, summation fy0, and moment of forces at any point is equal to 0. So these 3 are called as condition of equilibrium for the non-concurrent forces. Okay, so using the first condition, so again when we are going to use the conditions of equilibrium, the simple sign conventions we have to follow. Upward forces will take it as positive, downward negative, whereas rightward positive and leftward negative. So following these sign conventions, writing equations for summation fx, that means algebraic sum of horizontal component of forces, whatever forces which are horizontal, their algebraic sum we are going to take, and we are equating that sum to the 0. Okay, that simply means that equilibrium, that simply means whatever forces are in x direction, they will balance each other. Okay, so here FB rightward, therefore positive, then NA leftward, therefore negative, so FB minus NA is equal to 0. So you can write like this. For FB we can write 0.2 times NB, so 0.2 times NB is equal to NA. We can name it as equation number 1. Then using second condition, that will be summation Fy is equal to 0. That means algebraic sum of forces in vertical direction is equal to 0. That means whatever forces that act in a vertical direction, that will balance each other, and that will keep that force system in equilibrium. Okay, so again here upward force NB, so NB upward, therefore positive, minus 250 weight of the ladder, minus 800 weight of the man, plus FA, that will be friction force at point A, is equal to 0. So that will be equation for summation Fy is equal to 0. So again solving this, so we can write NB is equal to 250 plus 800 minus 0.2 into again here NA, So putting the value of NA from equation number 1 here, 0.2 times NB. So putting that value and solving for NB, so we will get value of NB as 1009.615. Okay, this is very simple. So NB here 0.2 times 0.2, so that will be 0.04, that will come towards the left. So here negative, that will be positive. So NB plus 0.04, NB is equal to 1050. So that will be 1.04, NB is equal to 1050. So value of NB will be 1050 divided by 1.04. Okay. So again putting this value in equation number 1, we will get value of NA. So that will be 201.923. Again putting this value in this equation, so FA is equal to 0.2 NA, so again we can get value of FA. Okay, then using third condition, so we are going to apply the third condition of equilibrium, that will be algebraic sum of moment of forces at any point. So here we are going to select the point B, so we are taking the moment of forces at this point, at point B. Okay, then simply while we taking the moment, we will require some perpendicular distance, and that calculation I have done here. Okay, so see that FBD and this diagram. Okay, so I point B, point A, this is point C, this is D and E. Okay, A B C D E. Okay, then while taking the moment of this weight of ladder, okay, 250 Newton weight, while taking the moment, this will be the perpendicular distance length BD. While taking the moment of 300, this will be the perpendicular distance BE. While taking the moment of force FA, so this will be the perpendicular distance, and while taking the moment of force NA, so this will be the perpendicular distance from point. We are going to take the moment of point B. Okay, so at FA parallel line and here perpendicular, so that will be same as this distance A to C. Okay, again this angle with vertical is given, so in triangle ABC, if we write sine of 30 degree, this is 30 degree angle, and if you write sine 30, that means sine of angle A, so that will be opposite side divided by hypotenuse, so that will be length BC divided by 5. So or we can write BC is equal to 5 times sine 30 degree. Okay, so the length BC. Similarly, for the length BE, for this length BE, for this length hypotenuse will be x, so that will be BE will be x sine 30, and for BD hypotenuse will be 2.5, so length BD will be 2.5 times sine 30 degree. Okay, then for this distance AC we have to use the cos trigonometry function. So cos of 30 degree, so that will be adjacent side divided by hypotenuse, so that will be AC divided by 5. So you can write AC is equal to 5 times cos of 30 degree. Okay, so that will be the calculation for the distances, and then we can write the equation for movement. Okay, so we are going to take the moment at point B. Okay, so we are taking moment at point B. So this 250 will cause a clockwise rotation. Okay, simple pen method you can use. So at point B we are going to take, so we will fix pen at point B. 250 Newton force is acting downward, so we will apply a downward force, and we will see that in which direction that pen is rotating. So it is rotating in clockwise direction. So again, so that will be plus 250 sine 30. Again sign conventions for the movement, so that they are clockwise movement as positive, whereas anti-clockwise movement we will take it as negative. Okay, so this 250 will cause a clockwise movement, therefore 250 into this distance. Okay, we have named it as BD. This is D point, this is E point, and this is C point. So BD, so that will be 2.5 sine 30. Again 800, this will also cause a clockwise movement, so plus 800 into x sine 30 minus FA. Now this FA will cause a anti-clockwise movement. Okay, we will fixing at point B. FA is upward acting, so am I applying upward force, it is rotating anti-clockwise direction. That means this FA force will cause an anti-clockwise rotation about point B. That is one of the method. Another method is you can imagine an imaginary x-axis and imaginary y-axis here. This FA force you can imagine it here and see that how this member is rotating. So it is rotating anti-clockwise. Therefore that FA will cause an anti-clockwise movement about point B. So minus FA into 5 sine 30, and that 5 sine 30 is nothing but this distance B to C. Then NA will also cause an anti-clockwise movement. Okay, this force is here, we can imagine it here, so again it is causing an anti-clockwise movement. then minus NA into 5 cos of 30. 5 cos 30 is this distance, perpendicular distance, is equal to 0. So while putting the value of FA and NA here, you will get value of X, and that will be nothing but your answer is equal to 1.657 meters. Okay, so if you have any doubt about this question, you can comment it on the comment section. Okay, thank you.